Okay, so let me explain this in here. So to store memory, right, to store data, we have different ways of doing this. We can use general purpose register. We can use memory in the .bss section or the initialize section, the data, right? But there is two things. General purpose register, the number of general purpose registers available for the in the CPU are limited, right? Now you guys are writing very simple programs. Sometimes you kind of come short of finding registers to basically store data temporarily, right? And you know that general purpose registers are fast because they are basically within the CPU, right? So you can send the data very quickly and get the data very quickly from them. But memory, when you have a memory map, the .bss is going to be kind of like out of CPU, right? So when you transfer data and get data, it kind of takes longer time to process those data. A stack is a mechanism because you have a different memory speed, basically, right? So a stack is kind of the speed of the stack when you access the stack. It's somehow between the general purpose registers and the external memory. So speed is something important for us. So this is one of the reasons we use the stack over the external memory, right? To have a faster processing speed as fairly close to using the general purpose register of the CPU. That's the reason we are maybe sometimes prefer to use a stack instead of external memory in .bss section and the .data section. So that's the philosophy behind it, for faster processing, okay? All right. As a programmer, when you're going to be using stack, especially when writing an assembly program, right? Map out the stack for yourself, okay? You go to your program and map out the stack, and for any push value that you have, right? And then see what happened to the stack, what goes into the stack. So that later on, when you go to the function, you know where is the data is where exactly, so that you can pick it up for processing. Okay, in this example in here, we said that you have two functions within your main body of the program, and the purpose is to implement this function using a stack. Previously, I guess it was last assignment that you guys practice implementing this using the call and jump function. So in there, we didn't say that, okay, the data has to be transferred to function through a stack. So you could transfer the data to your function through memory or through general purpose register. But the aim for this assignment is basically to use the stack to transfer data from the main body of your program to your function. So that's the purpose of this. And I want to like very quickly, if I can map out the skeleton of the program for you here, and go over it very quickly. It's a very simple program if you watch the lecture video. All right, so let me stop sharing this and open my whiteboard. Okay, let's grab a pen. All right, so we want to basically draw the skeleton of your program, right? So here you assume, let me, please. Okay, let's see if you have any question in the chat before I go over this. No, we haven't taken attendance yet. Okay, so this is the main body of the, since I'm writing on this, let me close my video. It's weird when I'm writing on the screen. Okay, this is the main body of your program. And this is where you implement your function, right? So this is where you define your basically global, for example, asm.main, right? And in there, you start saying that asm underscore main. And in here, you start basically your program, right? So we said that you can use the macro from the book to write this program. So I only write the most important part of the program. So we said that read two numbers from the standard input. So we call read integer function. Simple, right? I don't write the message to the user, okay, please enter one integer number and please enter the second integer number, or please write. So you do that yourself because I don't want to write the detail of it. Just want to write you the main skeleton, okay? Call read integer. So when you do this, then the integer value gonna go into EAX register, right? Then what you do here, you say that you wanna use the stack. So we push, sorry, it's not very convenient to write in here. Apologize if it is not very, it's gone. Okay, here. Okay, let's see. All right, so I have a Windows pen, and this Windows pen has eraser on it, and the whiteboard also has kind of eraser, and sometimes these two mix up. So call read integer, it goes into EAX, so we said that we want to use a stack, we push the EX value into the stack. Let's draw the stack over here. Okay, this is my stack, right? We said that let's do the convention that our stack grows upward, but as it grows upward, the address decreases. So we said that at the top, okay, assume we start from here. In top, there are something in the memory, right? You know that the stack is part of the memory map. At the top, you might have your .txt stored in here, right? So the stack grows in this direction, and the other code, they grow in this direction in the memory. So, okay, we first read the first integer, right? Assuming that we read, let's say, the integer n1 with some number, and assume that the stack is filled up to here. So when we basically push EX, it's gonna go in here. So we don't care what is in here. There's something in here, right? We don't care about that. So now n1 is in here. We read the second number, so it's gonna be called read integer. So this one is going to be our n2. Okay. So n2 is going to be in here. So when you say call read integer, it's gonna go into EAX. So I should have pushed EAX first before I tell you that it goes there. So second push, send n2 over the stack. So let me write down in here. This is my please collaborate with me. Okay. Okay, so this is my stack. Oh, it doesn't like, okay, I write it here. So this is a stack. If you're just joined here, so you know what we are doing. This is regarding the assignment for this week. So push EAX, it's gonna go in here and two. Now, I'm gonna call my function, right? So I put the numbers into the stack. I wanna call, for example, the multiplication function. So we say call mul function. So I call mul function, right? And once I call mul function, the mul function is going to calculate the value of the multiplication and then come back. Once it's come back, so we want to print that value to the on the screen, right? So therefore, I define a not a label. I don't need a label because the return gonna go after the call, gonna go to the next line. So when it's come back, then I want to basically print out the result. Call print integer. In your program, we're going to be sending some message to the user in here saying that, okay, the multiplication value for these two numbers is this. And then you print basically your number, right? I don't write it in here to save time. So you say call print integer and then call new line, right? And then you're going to have your call to the division function and then calculate the division value, come back and print it out. So I don't write the division function in here. It's going to be the same. So the important part for me in here is to implement mul function using a stack, right? Implement mul function using the stack. Therefore, at some point down below, I'm going to implement somewhere in here, I'm going to implement mul function, right? Mul function, right? So I'm gonna do that. So once I push EAX, N2 is going to be stored in here. And next line, when I call, use the call command, right? A function. So can anyone tell me after using call, what happened to the stack? This is very important.
The location of the call mul function was placed in the top of the stack.
You are very close, 90% close. When you say the location of call function, right? If it is, for example, L1, if it, sorry, it's writing very bad here. So can you tell me which location you are referring to?
The return location, the one right underneath it, so it can come back.
Exactly, that's perfect. What's your name?
Owen.
Owen? Okay, yes, yeah. That's correct. So as Owen has pointed out, when you use call function, right? If this is, for example, line 22, and this is line 23. So basically, the address of this command, which is like, assume that this is 23, it's going to be saved in the stack whenever you use call syntax. So therefore, we say return address. To make it more numerical, we say like 23, line 23. Okay, it goes there, right? And then we know, okay, so right now, ESP is pointing to here. ESP is pointing to here. So for this simple program, you can use the base pointer EBP register, or if you want, you just want to ignore that and do not use it because it's not a recursion function and it's not required. But if you want to use EBP, go ahead and use it. But if you don't want to use EBP, just use ESP, okay? So now we are within the function and we want to multiply these N1 and N2. So what is one of the way that we can access N1 and N2?
pop?
So if you say, okay, if you say pop right now, pop, that's correct. You can take one element from the top of the stack, right? If I say pop, what's your name? Sorry guys, if I'm asking.
Bennett.
Bennett. So when you say pop, you take the top of the stack, element from the top of the stack. And right now, top of our stack is the return address, right? So we don't want the return address. We want N2 and N1, right?
Right.
So how do we access that? There is another way, right? Do you guys remember?
Yeah.
Add 4 to the ESP register.
Add 4 to ESP register. If, remember that, if we add 4 to ESP register, then we basically, that means that the return address it get destroyed. You point out the ESP in here, then this element at the top is kind of automatically destroyed. That's, yes. So one, you're kind of right about this, but we don't basically, how can I say that? We don't just add ESP by 4. We access the ESP by 4. This is what you mean, right? We don't add ESP by 4. That's the different thing. So ESP is here. If we add 4 to it, we get access to the next element. But we want to access to that to take it out, right? The value of it. Therefore, we say move. For example, we're going to put it in which register? Let's put it like in EBX register. Move to EBX, what value? ESP plus 4, right? You meant this one, right? So basically the content of ESP plus 4. That's great. So then what? The other thing that you can do to basically simplify this is just move the other element to another register, so you don't need, or you can work directly with basically with the stack itself. So for the second element, what should be the value of the inside of the bracket? So now we take N2 into EBX. So here, N2 is going to be in the EBX. So in this line, what should we put to get access to N1?
Is it plus 8?
Exactly. So it's ESP plus 8 into ECX. So therefore you put N1 into ECX. Then the next line of your program simply would be IMAL EBX and ECX, which is going to go to EAX register. So let's put this one into EAX register, because if we use IMAL, we assume that one of the elements is in EAX register, right? Therefore, we use IMAL EBX, and this is going to automatically multiply EBX into EAX and put the result back into EBX and EBX register files. So once you do this, right? Okay, let's see, we have one question in the chat. Okay, it's this moving this stack. Okay, Alex, yes, basically we take the value of the take N1 and N2 from the stack and copy them to EBX and EX register. And then you multiply those value, and then the results now goes to EAX register, and if the result is bigger, then it goes to EDX concatenation with EAX register. Let's see, we have another question here. Okay, is there a way to do the multiplication using only one register? Yes, that's correct. We can do it using one register, Francesco. So what we can do is this. The first register, we consider that as EAX register, and then we can do multiplication. So this is the second way, guys, that we're gonna be doing this. So the question is that, can we do it using one register? So the answer is yes. So we take the first element and we put it in EAX register, EAX, and then we directly use IMAL, right? So we know IMAL can be used with one register EAX. The second argument can be register, or could be a memory address, or could be a stack address. So in this case, we use double word. We know that it's gonna be double word from a stack. Therefore, we use ESP plus 8. So what does this mean? This means that, okay, IMAL is going to multiply EAX with what? With the D word, double word, something double word from where? Double word from ESP plus 8, this location. So basically, a stack is memory, right? So when you work with it, all those things that applied for memory also can be used for the stack, for taking data, for moving within the stack, using the index in the stack, all those things that you have practiced for, like using external memory .pss and basically .data, also applied for the stack. It's the same. But the way that the stack increases and decreases is kind of different. And we have some additional function that only work with stack, like pop and push command. And also call function impacted stack, and return syntax also basically impact the stack. Okay, so this is the second line, right? So we have done this. So we did the multiplication. Now the result is stored in EAX value. Now we say return. Okay, so when we say return, what happens? Anyone knows? Where we go after return? So this is the next line.
To line 23.
Exactly. So we go back to line 23, and in here we call print integer. It's going to print out the value of the EAX register, which is the multiplication value. So if go back to line 23, what happened to the stack?
The return address was popped.
Exactly. So the return address is popped. It means that it gets removed from the stack, and now ESP pointer basically points to N2 location. And the good practice in programming is that when you basically use a stack, you save some parameters, intermediate value in there. Is you should be removing those value before if you do not need them, right? Now, since we need them, we let them stay in here. We go and implement, we call the division function. We use them N2 and N1. And basically, we come back. Once we come back, when we basically remove this value from the stack. How? So what is one of the mechanisms that we can remove the elements from the stack? So one is the pop command, right? When you say pop, it's gonna remove that value and the ESP gonna go one below, right? So what is the another way to do like 1,000 elements removal from the stack? How we can do this?
Putting pop in a loop of some sort?
That's one way to do it. So what's your name?
Alexa?
Alexa, yeah, that's one of the ways that you can do it. There is another way that takes much less time than that. Anyone knows?
Increase the stack pointer.
What's your name?
Oh, me?
Yeah.
Kai?
Kyle, sorry, I don't see your name on my screen when I'm sharing something. Sorry about that. Kyle, that's exactly correct. Thank you. Yeah, so the easy way is just using this. Let's write that. So you say add, for example, I want to remove 2 elements from the memory, right? You say add ESP 8, right? If you say add ESP 8, the value of ESP is going to be added by 8, and since each element is 4 bytes, then ESP is going to be pointing to this. So the thing that is important for us in the stack is the location of the ESP, right? Because whenever the ESP is above it, we are assumed that it's free. So we don't care what the value is at the top. So once ESP point at some location, right, at the top of the stack, so anything above it for us is garbage. Therefore, next time when you push something, it's gonna be pushed at where the ESP is pointing to. Basically one element above that. So that's the trick to basically remove the unwanted element from your stack. Very easy. So if you listen to the, if you watch the video lecture, I also explained on another way to do that. So basically the return can also take some argument. If you say return 8, the return address is gonna be popped up. Also, 8 byte in the stack is gonna be popped out. And basically your ESP gonna be moved down for 2 elements. Just please be patient and watch the lecture video. I know they are long, but they're very useful. They're very useful. I recommend everyone to watch it. Any question regarding the assignment? Is this clear for everyone? So I choose a simple implementation for this assignment. If you do this, it's acceptable. But if you could use the EBP register the way that I describe it in the video lecture, that would be great. Because that's the systematic way of using the stack. You basically use stack frame for each function, and base pointer basically creates a boundary between the frame for each function. So go through that, and you know, it is very interesting once you get familiar. And not only in assembly, right? In other high-level languages, if you want to write more efficient algorithm, you need to know how a stack is performing, especially for recursion function. Perfect. So let's stop here, and then let's go back to our lab. And thank you everybody for your feedback, and thank you everyone for you know, appreciating the course. The feedback were very positive. I really appreciate it. We have a few comments from few students. I want to talk to them regarding that. So if you haven't done the survey by now, please go ahead and do it. So this way I know which section or which part of the course need improvement, so that I can work on it and make it better. Okay. All right, so lab 10. So we want to talk about one of the, you know, interesting coding in computer science that normally you may deal with it. in other languages as well. And it's a good way to practice assembly. See if I can open this here and share it with you. Is anyone here that hasn't heard about ASCII coding? Okay, let me share this one with you. So what we want to do in this lab is basically in your keyboard, right? So there are different characters on your keyboard, right? So you have integer numbers, you have English alphabet, you have English alphabet could be capital letter, they could be a small letter, right? Depending on whether you press the caps lock or not. And the rest of them, for this lab, we call them a special character. So we're gonna be having 3 category of characters for your keyboard. So they're gonna be integer numbers, 1, 2, 3, 4, 2, 9 plus 0. They're gonna be English alphabet, a small and capital, and the rest of the characters on the keyboard, we call them a special character. So the task in this lab is to write an assembly program to basically classify the input string that you're entering into the system into these 3 categories. So you basically enter those values and your program are going to read those string and then take a look at the string and see if it is like a special character, you're gonna put it in a space belong to the special character. If it's integer in another class, if it is English alphabet in another class. By class, I don't mean the class that you're using in C language. I mean basically in a category of, so we're gonna have 3 categories. English alphabet, integer, and a special character. So you read one by one and take a look at the code, and you see that if this code is belong to, for example, a special character, you're going to be putting that value, that string into that bucket. Let's see this one. So to get the sense of the program, let me see if I can run the program and let you know what the expectation is from the program. And then we go and explain how we can implement it. Okay. So let me stop share and show you a demo of the program first, and then we go back and discuss how we can implement it, okay? So let's go to Linux, clear, okay, clear, okay, now we're here, and I have my run function, run to sh. Okay, so this is the program, assembly program char classification. So that's the name of the file. So let's run it. So it asks the user, please enter a string less than 30 character to classify. So we enter, for example, this, then we enter this, and some numbers, then some special character here, and then, for example, some number, right? So we enter this into the system, and the program is going to tell us the length of the string, for example, is 17. So it means that in here we have 17 different characters. It says that the integer characters are this one. So 441, 11, and 22. If you look at the string, so we have this 4 and this 112, right? And it says that the alphabet characters are this. QAWER. So if you take a look at that, you see this is our English, alphabet. So it separated the alphabet and print that out. And also it separated the special character and print that out. So the special character is $ and ampersand here. So it takes those and print it out in here. So this is the expectation from your program. So after basically implement the program, you should be getting similar results. So now let's come back to the table for the ASCII code and explain how you guys can implement this. All right, let me explain this table if you haven't seen this before. This might be a good time to understand the table and how basically we code the characters on the keyboard in a computer system. Okay, so in a computer system, right, when you have like your computer in here, let's see, okay, right in here. Yeah. Okay, you have your computer and then you have your keyboard, right? There are many basically keys on the keyboard, right? So how the computer knows, have you asked yourself how the computer knows what key you press at a given time? So basically once you press the key, what happened? Because, computer only understands 0 and 1, right? So, but this alphabet A, B, C, or a special character, they're not something that you can basically store in the memory, right? Therefore, each of these characters, they have an ID number. So for example, as like people, that each person has an ID and identification number, or basically an ID or social security number. For the keyboards, each character on the keyboard also has its own ID. And we define the ID of each character using ASCII code. So that when you press that a special key or any key on the keyboard, instead of that character going to be stored in the memory, because there's no way to do it, the ID of that character is going to be stored in the computer. Okay, so that's the basically idea. This is the idea. All right, so let's take a look at this and understand this together. Sorry. Okay, so these are so this part is belong to integer numbers, right? So the computer, okay. So if you take a look at this, you have numbers 0 to 9, right? And then at the top, you have the decimal value of the code, hex value of the code, octal value of the code, and HTML of the code. So this is your character. The character now on the keyboard that you're interested in for now is 0 to 9. Just focus on this for now. So the code for 0 is 48 in decimal, which is equivalent to 30 in hex, and 060 basically in octal, and ampersand this 48 value in HTML. So we don't care about those. Let's only focus on the value of the code in hex. So it doesn't matter which base you are presenting that value, but for simplicity, let's only consider the code in in hex, right? So let's consider the code in hex value. As you can see from here, for 0, it's going to be coded by 30 hex, for 1 by 31, and up to here for 9 by 39 hex. It means that when you press 0 on your keyboard, what is going to go into your computer, it's value 30 hex, which is in binary, is this one. So it's 1 byte, right? 0, 0, 0, 0. So this is hex, 0x. And then you have 1, 1, 0, 0. So when you press 0, the 30 hex is going to go to the computer. When you press number 9, what is going to go to computer? What is the bytes that is going to go to computer? Anyone knows? Take a look at the table and see what is the value, for example, in hex or decimal. So when I press 9, what is the value that's stored in the computer? This is 39 hex, and in binary is what value? That's 39 hex, correct? So we have what is the binary value? It is 1 byte, right? So what are the value? Correct. So the value from Jonathan is 00111001. Basically, this value is stored in the computer, not the value 9. So this is the way that computer understands 0 and 9. And if you want to process the data and numbers, right, after the computer, the ASCII coding and the data goes into the memory, then what you need to do is you need to decode that value. Basically, if it is 0, instead of 0, you're going to have 30 stored in the memory. You have to convert it back into a program to basically 0. You somehow subtract minus 30 from it, right? If it is 39, if you subtract minus 30, it's going to be 9. So, and then you start manipulating with data. The reason that you haven't seen this kind of ASCII coding and decoding in your all assembly codes is because you guys have been using the read integer macro and print integer macro from the textbook. So those, the function basically do the ASCII coding and decoding automatically for you. For example, read integer, when it's read the integer, it's basically read this hex code. And what it is stored for you, it basically decoded, it subtract. If it is 1 digit only, it's going to subtract 30 hex from it, and it's gonna store that value in the EX for you. So it does some processing behind the scene for you that you don't see. That was one of the reasons I said, okay, at the beginning, let's focus on implementing, using this function, because this make our assembly coding much easier and we don't care about the complexity behind. And now you understand what are doing behind the scene. And this, also print a string. Then you want to print a string of data, right? On the screen. For example, if you send 0, then the print a string function is going to code that to ASCII value and send that ASCII value to the screen, because the screen only understands the ASCII value because you have so many of them. And if you want to be able to present or show all these characters, you need to do ASCII coding before send it into the standard output device. Therefore, print a string also does a bit of processing for you, and it sends the data over. Okay, so the purpose of this lab is not to do ASCII coding and decoding. The purpose of this lab is only do basically the character classification. You enter some values and your program should do the classification and send it out, right? So now let's take a closer look to English alphabet for our input character. So let's see where they are. So English alphabet, they are stored from here down to here, right? So this is one portion for a small English letter. They're located here. So for example, what is the ASCII code for A? And then for the capital letter, they are stored in here. Right, so this portion of the ASCII code is related to capital A. So the ASCII code for A in hex is 61. So whenever you press A on the keyboard, the value that goes into the computer is 61 hex. If you press the capital 1A, the value that goes into the computer is 41 hex in here, right? Okay. The rest of this table are the special characters. So for example, null character, a start of heading character. So whatever it's remaining, for example, this one or a special character, this one or a special character, special character, special character, whatever is left here are special character. So considering this, when you want to write this program, so how do you do the classification? What is the idea?
You got to give it a range.
Okay. Can you give an example?
Like greater than 30 and less than 39 for the numbers.
Exactly. Yeah. So to catch the integer value, you check the ASCII code of the inputs, right? If they are within this range, you say that this character is an integer. No, that's correct. So how about for English alphabet? Anyone else know how to detect English alphabet from the ASCII code?
It would be greater than 40 and less than 7 or 5A, and greater than 61 and less than 7A.
Exactly. So you check the range of your inputs for the ASCII code. If they are within either of these purple number, X number, then you say that this character belongs to the English alphabet. So what is the mechanism for the special character? So what is the idea? How do we detect the rest of them?
Can we say anything not in those ranges?
Exactly. So I can't see your name. What's your name?
Rocky.
Rocky, that's the good answer. It's perfectly correct. So as Rocky has mentioned, so you basically check the ASCII code that come into the computer, right? Then you have some ranges in your table, ASCII table, right? You take a look at that table, see where is the range, and find, okay, fall in which basically section. Does it fall in the range for the integer number? Did you say that's integer? Does it fall in the range for the English alphabet? To say English alphabet. If it does not fall within these two ranges, you say that it's a special character. That's the one good way to do it. That's the basically only way to do it. But how basically you are going to there are going to be some jump instruction, right? Some jump and conditional statement instruction involved in your code, basically. So there are many ways to basically detect this range, right? For using the like kind of if and else condition. But there is one that is much simpler than that. There is one way to implement all these if and else condition in a much convenient way. The way that we describe it so far is logically correct, but if you want to just, for example, start with integer number and say that if it is in this range, going to be integer, then you're going to say if it is in this range of alphabet, that's going to be alphabet, and then the rest is a special character. It works, but your program going to be very long. So what is the efficient way of doing this? So assume that a user basically press the question mark, right? So once the user press the question mark, what is going to go to the computer? It's a bad computer. So this is my keyboard. Let's make the keyboard blue. Okay, so when we press the question mark, what's the value that transferred to the computer? Okay. 6. Okay, Rock said 111. Anyone else has any suggestion? Is this correct? Yeah, that's the same. Yes, it is correct. So basically, when you press that, there's going to be 3F. When you convert 3F in binary, so the first 4 is going to be 1, the second 2 is going to be 1, and then the other 2 are going to be 0. This is correct. So this is the value that we're interested in, right? So when we write our program, then we have to implement some if and else condition for it. So the simpler way that I want to write the pseudocode for you guys is to do this. So assume that we press 3F and we want to check that. We say, let's start from here. We say, if, right, assume that that value goes into, you know, it is a pseudocode, it's not assembly code. Okay, assume that that value, if x is x, so we say if x less than, so take a look at these special character, right? So all of them are a special character, right? All of them are a special character up to where? Up to here. So this is a special character and this is a special character. We say that if x is less than 30 hex, 0x30, if it's less than that, then we store x in a special character in the memory. So assume that we have defined a special character at the beginning of the program. So once we know that something belongs to a range, we store it in there so that later on, after this loop is completed, we come back and print those out to the screen. So for now, assume that the special character is a place in the memory that we store those values in here, right? So we say that if x is less than 30 hex, then it is going to be a special character, therefore x is going to be a special character. Else, if x is less than, okay, let's see what's the boundary for integer numbers, 3a. So we say that if x is less than that, it's going to be a special character. Now we check if it is less than 3a, then we say x is belong to the integer number. So and we create the integer number section in the memory. integer numbers. We send that, basically, this is the kind of store. We store that value in the integer numbers. If not, if the code that you're getting is not belonging in these two range, then we check the next range. So the next range is going to be from here to up to here. And it's a special character. Since alphabet starts from here, right? We say if it is less than 41, then it's going to be a special character. So else, if x is less than 41, then x will be stored in a special character. Sorry if my handwriting is bad. I'm writing on the desktop, so it's moving a lot. So, okay, if x is less than 41, yeah. So if x is not belong to this range, it goes to the next one. If not belong to this range, goes to the next one. It check if it is less than 41 hex. Then we say that it is a special character. And if not, if that value of the code is not there, if that range, we say else, if x is less than what? So we check the alphabet character and the last numbers that they have is in here. So the boundary is 5b. We say if it is less than 0x5b, then x gonna be stored in English alphabet section. So we say English alphabet. Sorry if this one not clear. So this is a container that we have created at the beginning of the program for the English alphabet. And you continue like that. So the next one are going to be these guys up to here. So we say that if x is less than this 61, it's going to be a special character. And the next boundary for you is this one. We say that if it's less than 7b, is going to be English alphabet. And else is going to be, if it's going to be less than or equal to 7f, then it's going to be a special character like this. And then you have the last one. If the code is something different than this, then you print out an error message saying that it is out of the range, which basically for your program, you will never get there unless there might be an error in your code. So this is the simplest way to basically implement your conditional loop. You can do it the other way that we discussed at the beginning, but that's going to be a bit more lengthy. I don't say complex, but it's going to be a bit more lengthier. Okay, let's, any question about this pseudocode? Okay, the concept is simple, it's not very complicated, but the way that you code it could be different from everybody else. One of the other points that you guys need to know about this program is that we said read integer or read, basically we said read integer and the other one called read a string, right? We had that one too. Those basically gonna do the decoding from the ASCII code, right? That's so you don't want to do the decoding because you want to basically classify those based on the ASCII coding, right? Therefore, you cannot use those functions. If you use the read function from a read macro from the textbook, it's going to decode this for you, but you don't want the decode version of this code. You want the true value of the code, right? Therefore, you need to implement your own print this, read the string function. Okay, so you need to do that. Anybody knows how we basically read from the memory without using those macro?
Using an interrupt system call.
Exactly. That's correct. So again, I didn't see your name. What's your name?
Kai.
Yes, that's exactly correct. So Kai, can you explain which register we need to program to basically ask the system read something from the keyboard? What are the registers that we need to program?
I don't really remember, but I think the code for reading standard in Linux is 4, but I don't remember what register to put it in. Might be
Okay.
EAX.
All right, so let's see that. I think in the assignment description, I somehow I might have mentioned that. Let me take a look at that.
Oh yeah, I didn't actually read the lab.
That's okay. That's okay. Okay, let me share this with you guys. Okay. All right, perfect. So instead of like using the book read function and print function, you need to basically implement your own read function to basically save your time. I have provided one code in here for you to use. Okay, so this is the read string function. So basically in your code, at the beginning of the program, you will say the user to enter some string values. And after the user basically saw the message, is gonna enter some characters from the keyboard. And then you're gonna be reading those. To read those, you will call this read string function. Or you can implement your own read string function. As we explained in the beginning of the course, we said there are 2 ways to read and print out this course. One is using the book macro. The other one is using the Linux interrupt system, where you basically program your EAX, EBX, and ECX and EDX register, right? And then you call the interrupt, you call the kernel system by using this syntax, INT hex. You call the kernel, okay, I have programmed these registers and I have a task for you. Can you please do this task for me? Then the system gonna take a look at that. Take a look at the EAX value. It sees that it's 3. It means that it is read. Then it goes to the keyboard and wait for the keyboard to see what characters enter into the system. If EAX is 4, it goes to the screen, right? It says that, okay, I have to do something with the monitor, right? Now, since EAX is 3, it's known that it is going to be the standard input. Basically, it's the system read, and then the second number, EDX, it says that it is basically the standard input, because you can have multiple I/O that could act as input for your system, right? You could read data from your mouse, from your keyboard, or from any other I/O. For example, graphic card also can act as an input for your system. So, and that has a different ID number. So since the ID number for EDX is 2, it knows that is the keyboard. And then, okay, now I want to read some value from the keyboard. Where should I put those values, right? So the value that you're going to put there, basically you say that I'm going to read this string value, basically put it into the memory where it's pointed by ECX. And then what is the length of it? The length of it is going to be a string length. And then you call the kernel, and once you read those values, you are going to be returned. So now you read the value, and the value are stored in the memory in the string location. So then instead of dealing with memory, with the keyboard to read the data, the data right now is stored in the memory. You take character by character and check the code, the ASCII code, and see which range is belong to. And then from there, you have three different buckets. The first bucket for example, alphabet, integer, and a special character. You read one by one, and then you basically do the classification. And then, so if this is the string in your memory, right? You have all those bytes in here, for example, A, 3, a special character, number sign, question mark, number sign, for example, 2. You read one by one. We take A, right? And then in your program, you create three basically bucket. In the memory one, you call it alphabet. Alphabet storage is going to be for your alphabet, and the second one for your integer number, and third one for your special character. So you take this first, you compare with those range. Now you understand that it's belong to the alphabet. So you put it in the alphabet section. You put it, for example, in here, A, right? And then you read the second number from the memory. You check it using if and else statement. And then you put it in the second counter, right? You put it in here, 3. You read the third one. You check in your program. You put it in the another counter here. So once you classified all those, okay, one thing else I want to tell you, the last character in your string is going to be 0xa. To check whether you arrive at the end of the string value, you check your character. If it is 0xa, it means you are done. There is no more character. So in your loop, you have to check if it is 0x1. So once you click, basically hit enter for your string, when it comes to the system, it automatically create a 0xa value at the end of your string telling the system. This is the, if you reach to this value, it means that that's the end of the string. It is when then you exit from your loop and you print out, you know, the 3 counter, the 3 bucket that you have classified. So once you do that, come up with these 3, you start printing that out, the first one, second one, and the third one. Any question? Okay, and also for the print function, you have something over here. You have print a string value for yourself as well. As I said, you cannot use the macro from the book. You have to write your own function. This is going to be your own print a string function. You can write your own, or you can use this. Do it EX will be 4, EDX will be 1. The string is the location of the you know, values in the memory that you want to print out, and this is the length of those things. So, for example, for your alphabet in here, the string, you have basically a label that's pointing to this location, and you need to put that label in here. Okay. Any question about the concept of this? How you basically do this? So I didn't say for this one use a stack or not. So you're free to use memory or a stack, whichever you feel more comfortable with. So one thing I want to let you guys know, please go through the lab and read each section carefully. You draw your flowchart to understand how your code should be. And then these are the materials, reading materials for ASCII code. Please go through them to understand more. And then read the instruction carefully so that you don't have any issues implementing your code. If you understand it, 50% of the solution is to understand the problem. Try to understand it first and then start writing your program. Your program is going to be, nothing special going to be in your program. There's only jump and conditional loop. And these two functions also has been written for you so that you can take an advantage of it and use it. In case you have any question, you can post it in the discussion board or reach out to me or the tutor. So don't stuck. If you try and you said that you stuck in a place that